Imagine this. The Earth shudders, the skies darken, and chaos erupts on a planetary scale. Sounds like the end of days, right? Well, for the dinosaurs, it kind of was. Hey everyone, get ready for a deep dive into one of the most devastating extinction events in Earth's history. But this isn't just your typical asteroid hit story. We're not just talking about the well-known Chicxulub impact in Mexico, the one we all heard about in documentaries and school textbooks. You know, that massive asteroid that slammed into the Yucatan Peninsula and basically hit the reset button on Earth's biosphere? Yeah, that one. But what if I told you there's more to this prehistoric doomsday tale than just one killer rock from outer space? Let's lay down the facts. The Chicxulub impact has long been the main culprit behind the sudden extinction of the dinosaurs. And honestly, it's not hard to see why. This thing wasn't just a space pebble, it was a planetary wrecking ball. It created a monstrous crater over 180 kilometers wide, shot molten debris high into the atmosphere, ignited global wildfires, sent the planet into a deep freeze, and kicked off a deadly domino effect that wiped out about 75% of all life. It was chaos on a global scale. But here's where the story takes a wild turn. What if Chicxulub wasn't acting alone? What if there was another cosmic hit job happening right around the same time? Enter the Nadir crater. Never heard of it? Don't worry, you're not alone. Until recently, even many scientists hadn't. But now it's starting to make serious waves, literally and figuratively. Discovered beneath the Atlantic Ocean just off the coast of West Africa, the Nadir crater could change everything we thought we knew about the day the dinosaurs died. And here's the kicker, it's incredibly well preserved. While most craters get eroded away by wind, water, and time, this one stayed hidden and protected, sealed beneath layers of seabed sediment for millions of years. It's like a prehistoric time capsule waiting to be opened. Thanks to groundbreaking 3D seismic imaging technology, scientists are now able to peer beneath the ocean floor and see this buried relic with stunning clarity. And what they've found is nothing short of mind-blowing. The crater is about 9.2 kilometers across. Now that's no Chicxulub in size, but it's still a big deal. An asteroid big enough to make a crater that wide could easily destroy a continent-sized area if it hit today. And what's even more jaw-dropping is the surrounding blast zone, an outer ring nearly 23 kilometers across where the seafloor is all churned up and deformed. Think about the sheer energy needed to punch through the ocean and mess up the seabed that badly. It's like someone took a wrecking ball to the planet. This isn't just about size or location though. It's about what the crater reveals. Inside, the structure is textbook impact zone. A central peak where the ground rebounded after the collision, terraced walls where the rock collapsed inward, and strange shifts in the surrounding rock layers. These shifts aren't minor, they're significant enough to show up as changes in velocity in seismic scans. Translation? The impact actually altered the rock on a molecular level. We're talking heat, pressure, and force so extreme that it changed the physical structure of Earth's crust. That's not just a big bang, it's geological surgery. This brings us to the most intense part, what this means on a global scale. See, Chicxulub was already enough to mess up the entire planet. But if Nadir happened around the same time, then we're not looking at a single event, we're looking at a cosmic 1-2 punch. Imagine a scenario where Earth gets hit by one devastating asteroid, and before it can recover, gets slammed again from another direction. 2 extinction-level events in rapid succession. That could mean even more prolonged climate chaos, intensified ocean acidification, and a total collapse of food chains. For the dinosaurs, it wouldn't have just been one bad day. It could have been a whole season of death. So how do scientists figure out the direction of these ancient impacts? This is where the crater's asymmetry comes into play. One side of the Nadir crater's rim is noticeably steeper, which tells us the asteroid came in at a low angle from the east-northeast. Picture a bullet ricocheting off a surface. It leaves a very specific mark. This angle not only helps us reconstruct the trajectory of the impactor, but it might also help us link it back to other objects, including Chicxulub. Because here's the big theory. What if Chicxulub and Nadir were part of the same original space rock? Sounds wild, right? But it's actually pretty plausible. In the chaos of the solar system, it's not uncommon for a larger asteroid or comet to break apart near Earth due to gravitational forces or even earlier collisions. This could create multiple impactors from a single body, all hurtling toward Earth in a spread pattern. Think of it like a cosmic shotgun blast. Chicxulub and Nadir might just be 2 pellets from the same devastating shot. That would mean Earth didn't just get unlucky with one asteroid, it got caught in the middle of a whole celestial hailstorm. This theory could also explain some of the strange inconsistencies in the fossil record. Some scientists have noticed that extinction rates and environmental stress markers don't all line up perfectly with Chicxulub alone. But if you throw in a second impact, or even a cluster of smaller ones, that timeline starts to make a lot more sense. Instead of one instant apocalypse, there could have been waves of destruction spread over days, weeks, or even months. It paints a picture of a planet under siege, where ecosystems were being hammered repeatedly, each blow pushing life closer to the brink. All of this elevates the Nadir crater from a geological curiosity to a potential missing piece of the extinction puzzle. It challenges the idea of a singular cause and opens the door to a more complex, layered story, one that involves not just massive space rocks but also timing, sequence, and cascading effects. It reminds us that Earth's history is written not just in stone, but in scars, some of which are still hidden beneath oceans and deserts, waiting to be discovered. And this is just the beginning. In Part 2 we'll explore the timeline in more detail. How close did Nadir hit to Chicxulub? Were they days apart? Hours? What do we know about the size, speed, and composition of these impactors? And most chilling of all, could something like this happen again? Don't go anywhere because this extinction story is just heating up. Now, let's talk about the aftermath, the consequences for the planet if this Nadir impact really happened. Let's just say it wouldn't be pretty. In fact, it would have been one of the worst days to be alive in Earth's history. We're not talking about a local disaster. This would have had global implications. But wait, you might wonder, since Nadir struck the ocean and not the land, wouldn't the effects have been less severe than the famous Chicxulub impact in Mexico? That seems logical, right? After all, water might cushion the blow. But surprisingly, that's a common misconception. A lot of people assume an ocean impact would be less destructive, but that's not exactly true. In fact, land impacts might hurl more dust into the atmosphere initially, but underwater impacts bring their own brand of devastation. When a giant asteroid smashes into the ocean, it's not just a splash. It's chaos on a scale we can barely imagine. You're looking at absolutely massive tsunamis, waves hundreds of feet tall, racing away from the impact zone and demolishing coastlines thousands of miles away. That's just one part of the nightmare. Then there's something even more disturbing: liquefaction. Imagine the sea floor suddenly behaving like quicksand. That's what liquefaction is. It happens when the intense shock waves from the impact shake the sediment on the ocean floor so violently that it loses all structural integrity. The seabed, normally firm and solid, suddenly turns into something fluid. That means massive underwater landslides, oceanic structures collapsing, and total havoc in marine ecosystems. Sea creatures wouldn't stand a chance. Even if you were lucky enough to be far from the actual impact and escape the mega tsunamis, you'd still be left with a dramatically altered ocean landscape. This isn't just some regional disaster we're talking about, it's a global ecological crisis. The magnitude of destruction from a deep-sea impact like Nadir would have rippled across the entire planet. Whole ecosystems wiped out, weather patterns disrupted, food chains collapsing. It's not just doom and gloom, it's the kind of cataclysm that changes the course of life on Earth. And yet, what's even more mind-blowing is that we've only just discovered this crater. So before we get lost in imagining how bad it was, let's break it down. What exactly would the step-by-step impact event have looked like? Alright, close your eyes and picture this. A giant asteroid, possibly over 8 kilometers wide, hurtling toward Earth at breakneck speed. It smashes into the ocean, instantly releasing energy equivalent to thousands of nuclear bombs. The shockwave from the impact would vaporize anything in its immediate vicinity: water, marine life, and even solid rock. The force would be so intense, it would compress and superheat the Earth's crust below the ocean floor. That's when the crater starts to form, and this all happens within milliseconds. You're not watching this unfold, you're barely able to comprehend it. Think of it like dropping a pebble into a pond, except this time, the pond is the Atlantic Ocean and the pebble is a chunk of space rock large enough to destroy life. The water erupts outward. The crater expands at an astonishing rate, and the surrounding seabed collapses. But water doesn't just disappear. It needs to go somewhere. And that's when the first monstrous tsunami wave forms, rising higher than skyscrapers, moving faster than a jet plane. This isn't a single wave either. It's a series of destructive surges spreading outward across the globe. And just when you think the horror is over, here comes the second punch, the backwash. After the initial mega tsunami surges away, the enormous void left behind at the impact site pulls surrounding water back in. The sea rushes into the crater with devastating force, creating what scientists call the resurge. This secondary wave might be just as destructive, if not worse, than the first. Like the ocean is playing a giant game of ping pong with walls of water. And each time the water slams into the crater again, it churns up more rock and debris. This relentless back-and-forth motion carves the crater deeper and wider. Sediments and rocks get mixed up, forming layers of chaotic, jumbled deposits. And we've actually seen that evidence, thanks to modern 3D imaging technology. Scientists have mapped the structure of the Nadir crater in incredible detail. You can literally see the chaotic layers that were formed by this violent process. It's like a geological crime scene frozen in time. And it's those layers, those disturbed strata, that prove something massive, something earth-shattering, happened in that spot millions of years ago. It really makes you appreciate the raw, unstoppable power of nature, or, in this case, the universe. A chunk of rock from space slamming into Earth with enough force to reshape continents. When you zoom out and look at the big picture, it's humbling. You start to realize how small we are. But here's where things get even more fascinating. Let's talk about Nadir and Chicxulub together. Two massive impact sites. One in the ocean. One on land. And not all that far apart in time. Could they be connected? Could they be part of the same catastrophic event? That's the million-dollar question, isn't it? What are the odds that two massive impacts happen so close together, around the same time in Earth's history? If Nadir really struck Earth around the same time as Chicxulub, roughly 66 million years ago, it raises the possibility that these weren't isolated events. Maybe they were fragments of a larger asteroid or comet that broke apart as it approached Earth. If that's true, then we're not talking about one smoking gun for the dinosaur extinction, we're talking about multiple bullets fired at the same time. Imagine that, a cluster of enormous space rocks hurtling toward Earth, each capable of global destruction on its own. That would mean the dinosaurs weren't just wiped out by a single impact, but by a series of impacts. Tsunamis pounding the coastlines, entire habitats collapsing, sea floors liquefying. It paints a much darker, much more chaotic picture than we ever imagined. And it could change everything we thought we knew about the end of the Cretaceous period. Suddenly it's not just about Chicxulub. It's about a whole series of events that rewrote life on Earth. And what's even more incredible is that we never would have known about Nadir without the latest in 3D subsurface imaging technology. This crater was completely hidden under the ocean, buried beneath layers of sediment and water. It took high-resolution sonar mapping and seismic data to reveal what was down there. Without that tech, we'd still be in the dark. Now, we're able to look deep into Earth's history in ways that were never possible before. It's like having X-ray vision for the planet. We can literally peel back time. This kind of discovery makes you realize how much we still have to learn. If Nadir stayed hidden for this long, what else is out there? How many more craters, fossils, or buried secrets are lying beneath our oceans or deserts, just waiting to be discovered? And beyond the excitement of discovery, there's a serious question hanging over all this. Could this happen again? If a catastrophe like Nadir struck millions of years ago, is there any reason to think it couldn't happen in our lifetime? Unfortunately, the answer is yes, it absolutely could. Space is full of surprises. We might not know when or where the next big asteroid will come from, but we know Earth is constantly being hit by smaller objects. Most burn up harmlessly in our atmosphere, but some don't. Some sneak past our defenses. And all it takes is one rock, one wrong angle, one moment. That's why the Nadir discovery is more than a cool geological find. It's a warning. A reminder that Earth has been struck before and it could be struck again. It's not a matter of if but when. But that doesn't mean we're helpless. Far from it. The more we understand these ancient impacts, their causes, their effects, their frequency, the better prepared we can be for the future. One day, with the right technology and early warning systems, we might actually be able to spot an incoming asteroid and deflect it. Prevent another extinction-level event. But until then, all we can do is study the past and learn everything we can from craters like Nadir. It's our best shot at protecting the planet we call home. Still, even with all we've learned, Nadir leaves us with more questions than answers. What exactly caused it? Was it really linked to Chicxulub? And if so, what does that mean for our understanding of Earth's most famous extinction event? That's what makes science so exciting. Every discovery opens up a dozen new mysteries. And Nadir, without a doubt, has shaken up everything we thought we knew about the final days of the dinosaurs. Who knows what we'll uncover next? The story is far from over. And that brings us to the end of our deep dive into the mysteries of the Nadir crater. It's been quite a journey, from underwater tsunamis to extinction theories, from space rocks to seismic scans. If nothing else, this discovery reminds us of how fragile and unpredictable life on Earth really is. We're just a tiny part of something much bigger, caught in the endless dance of cosmic events. And as our technology improves, maybe we'll find even more hidden stories beneath our feet and oceans. Until then, keep asking questions. Stay curious. And who knows? Maybe the next discovery really will be earth-shattering.